Hello everyone, hope you guys are doing great. So today we are going to discuss a new problem, that is the educational Codeforces around 189. Then the problem number is C, named as red black pairs. So first we understand the problem. Okay, so it is given a 2 cross n cells and each cell of the table is colored either red or black. That means we have given a 2 cross n matrix and each cell will contain either red or black, and we have to repaint some cells of this table so that there exists at least one way to partition all cells into n pairs such that the following condition holds. That means we have to repaint some cells so that we can partition the whole matrix into n pairs that satisfy the following conditions, like the cell in each pair have the same color. That means we have to make pairs in a way that has the same color, and the cells in each pair share a side. That means the pair we are choosing should share a side, like if it is 2 cross n cells, it is like 2 horizontal or 2 vertical we can take as pair, and we have to find the minimum number of cells that need to be repainted. So this is the whole problem. If I brief it, that we are given 2 cross n cells, like there are 2 rows and n columns, and in each cell either will be a red or a black, and we have to make n pairs, and we can make pairs like either taking two continuous cells in one row or 2 vertical cells as a pair, because there is only 2 rows. And we have to take care that we are choosing which pair that should contain the same color. That means if there is red in the pair, then it is okay, but if there is red and black, then we have to invert either red to black or black to red, and so that the pair contains the same color. And we have to find the minimum number of cells that need to be repainted. That means we have to invert red to black or black to red minimum time, so that the object can take the n pairs and every pair has same color. So this is the question, this is the input, and this is the output. In output we have to print the minimum number of cells that need to be repainted, like in this example. Okay, so let's discuss the problem in a more detailed way and try to build a solution. Okay, so what we are given, let's first discuss what we have given. So we are given a 2 cross n matrix, something like this. We have given a 2 cross n matrix. Okay, either it will contain either red or black. Okay, either red or black. And what we have to do, we have to count the minimum number of flips. Count minimum number of flips. Flips क्या, what? Red to black or black to red. Okay, this is the flips we have to make. Count minimum number of flips, so that each pair, that is each n pair we have have same colors in both cells, and the pair is of 2, you know already. This is the condition we have given with. Okay, so we count minimum number of flips so that each n pair have same color in n cells. And let me explain you how to choose the pair. Suppose there is like red, black, and then red, black, and then we have like something black, then red, then black, then red. Now how to check the pair? They are saying that we have to make n pairs so that they will share at least one side. That means we can take pair either like these two or like this first and this second as a pair, either two horizontal or one vertical like this. I hope you can understand. We have to make pairs in such a way, and we have to count minimum number of flips. Suppose in this example, if we have to make n pairs, here I can see that this is two red, it is already made. This part is done. Here we can make a pair of this two pairs. These two pairs are made without any flip, and we can make, to make this pair we have to make one flip, and to make this pair we have to make one flip. Either we can convert black to red or red to black. This will satisfy condition. So to make 4 pairs we need 2 flips. That will be minimum. And if we try another like vertical, like if we take this 2 as vertical, then this 2 as horizontal, and this as vertical, then it will need 4 flips. So we have to anyhow make it like a minimum number of flips we have to done, so that each n pair have the same color. Okay, let's discuss some of the examples to get a more depth understanding of the problem. Suppose there is like in this problem RBR and BRB. Okay, RBR, there is RBR and BR and B. In this, if we try to make pair, if we take these two and these two as horizontal, we need 2 flips in both, one flips in both to make them same, and this one will remain, and so we have to make it as horizontal, I mean vertical. Then it will also need 1 flip, so there are total minimum 3 flips. We have to make 3 pairs, so the answer should also be 3. Okay, now for this RRBB, let's discuss this again. So minimum flips needed is 3, and for this example RRBB and BBRB. Okay, so in this, if we take go greedily, we can see these two dots are, we can check for horizontal and for vertical, in which we don't have to flip, we will choose that if we go with greedily approach. So here we choose horizontal because in vertical we need a flip. So if you take this as a 1 pair and this is a 1 pair, we don't need any flips, so 2 pairs have made. And if you take this as 1, there 3 pairs are made without any flip, but in the 4th we have to make 1 flip. So we can see here the minimum flips needed as 1. Okay, minimum flips needed as 1, and in the answer you can see also as 1. Now if you discuss this 5th, that is RBR, BR. What is RBR? RBR, RBR, BR, RBR, BR, and just wait a minute. BBBRB, BBBRB. So if you think in this and we choose greedily, so I can see that we can make this pair as a vertical. If we take these to be as vertical, we need no flips, and I think for each we have to make flip. So there is n is 5, and we have to make 5 pairs. 1 pair can be made with 1 without any flip, and all 4 should need a flip. So here I can see the minimum flips needed will be 4, and the answer is also 4. So till now I hope everyone got the understanding of the problem. Now we have to think how to solve this problem so that we can take minimum, we can count the minimum flips. So if you think some greedy approaches, like we can start from first and check for horizontal and vertical, in which, like here, these two verticals are equal, then we will choose that, not go with that. Then go to other, like we can think some greedy approaches, but I prefer use DP, like because when we have to count the minimum flips, so we can get intuition, like if in the question something like minimum, if question is asking minimum and maximum, so we can kind of think of recursion, DP. These approaches comes in our mind, and we can here simply see that if you try out all the possible situations and check the minimum, which take minimum, we can solve this problem in that manner. Okay, so I can see that so how we proceed if we try to use recursion to take minimum. So we will start from first. Okay, let's think how to go. We will start from first. Now I can go either horizontal and vertical to make a pair. Now I will not use any greedy. We are using recursion, a simple checking all the steps. Now if I first check for the first, I will take the horizontal one, then I will take the vertical one and return the minimum that will be written by the overall. Okay, so we first take the minimum. So let us build how, what if you use recursion. Now recursion approach, how we will use that. Okay, so we start from first, as it is the matrix, we can say that we start from 0 0 simply. Okay, we start from first, that is 0 0. What we do, we will first try to make the pair vertical. If we try to make the pair vertical, so what we do is we will compare the what, suppose the current is ij, I will compare the ij with I plus 1j. If you are traversing in the matrix and I is for row and j is for column, we start from first. If we go vertically, like for vertical pair, if we choose the vertical pair, we compare ij with I plus 1j. Okay, so let me take this with my example here below. Okay, suppose in this, if we first make the vertical pair, then we will compare ij. Suppose we are currently at ij and we compare with the one below, that is I plus 1j. If these two, there will be only two conditions in this, only two conditions will there. What is the condition? The first condition will be that these two are equal. These two are equal in pair. So we just check for recursion for what? Now if these two are equal, we pass our control to this one, that is go with the same I with j plus 1, check j plus 1. Okay, and if second condition not equal, these two are not equal, then we have to make a flip. Then what we'll do, while returning we add 1 plus, then check for other, that is the same I and j plus 1. This is simple. If these two are equal, we check for this. If not equal, then we may have to make a flip, then we add 1 and check for other. and finally we will return. So this is the, for vertical pair we have these situations. Okay, so now for if you are making the horizontal pair, okay, now if you are making the horizontal pair like this, if we are making this pair and we are currently at this position, that is ijr00, you can say, then either this will be equal, the same condition, equal, not equal. If equal, then no need of adding +1, we will directly go there. Why we go there? Can anybody say me? Yes, there is the trick. If we are choosing horizontal pair, then automatically for bottom there is only one condition left, that we have to choose that also horizontal. We can't do anything with this. If we are choosing the upper one as horizontal, then we have to check in the horizontal manner for these two also, and the control flow should go to this directly. A new problem here created. Now these are independent, these are solved, these four are solved. Now we have to start from here. I think, let me explain again. Suppose if you are taking the horizontal pair, okay, I am saying that I will then for next recursion I will start from this position. Why? The trick is, if we are taking this as horizontal, then for below we also have to take it horizontal, because for this there is no option for vertical. So overall these four are already solved, and we have this is now a new problem, a new recursion here occurs. Now I think you are understood it. Okay, so for horizontal what I will do, just simple, there is like many conditions. First condition, there are many. First condition will be what? Let me explain the conditions to you. If these two are equal and these two are equal, that is the I and j are equal to I and j plus 1, and then the I plus 1, that is I plus 1 comma j, that is this one, and this is also equal to I plus 1 comma j plus 1, that is this. What I am doing, I am just comparing these two and these two. If both pairs are equal, then we just have to go for what? Go for to check what? The same I, but this time j plus 2. Okay. What will be the second condition come? The second will be like if I and j is not equal to I and j plus 1, that is this is not equal and this is equal. Okay, this is not equal and this I plus 1 and j is equal to I plus 1 and j plus 1. This is the condition. Okay, if these two are equal, we just get to go for what? Next, I and j plus 2, but as this pair is not equal, we had to make one flip. So while returning, go for check, but while returning, add 1. That when this return the count from here to we will add 1 in that returned value. Okay, what is the third condition? Third will be the else condition. Like, which is remaining, that this is also not equal, this is also not equal, so we will just go to check the same ij plus 2, that is in this situation. Now you tell me what we have to return. While returning, what have to add? Two flips. two flips out there. So I have covered the vertical pair approach and the horizontal pair approach. So this one I can also go from there. There is a edge case like in the recursion approach when we are going for vertical pair. If you are going for vertical, then we can check for all without any problem. But if you are going taking verticals, but what if the n is odd? That is, there is again an r and there is a b, something like this. Then in one case, if these two are make pair, then this pair are make, then we don't have to consider the horizontal pair from here. We only can take the vertical pair. So also make sure to check that your I is not equal to n minus 1 for horizontal pair. Okay, sorry, not I, j, that is the column. Your column is not equal to n minus 1. This is for the horizontal pair, vertical pair, and at the end we just have what to do. Suppose for one I choose the vertical and check for next, and in the second I go for horizontal and check for others, and at the end we just have to return the minimum of horizontal and the vertical counts. So this is the approach. We can calculate the minimum number of flips using recursion. Now let us try to make this intuition or the logic, or you can say approach, in the code format. I hope everything is understandable here. So let us try to write the code for this. Okay. So let's start coding. So first we include all the libraries, then we store the namespace. There will be a main function and there will be 0. There will be 10 test cases. I think each test case contains multiple test cases. Yeah, this t, and we have taken as that as input. Now for all test cases we run our code. Okay, so let me first make these comments. Comment it out. Okay, no. Now we have this t minus 1, and what we are given is the first line of the test case contains one integer n. That is, this is n. That is the number of columns. We have taken the n as input. Then there is, let me little bit screen size. Okay. Then the second and third lines of each test contain the colors of the cells. Each line contains a string consisting of exactly n letters R and B. So there is an string comes. Let me take it as first, and string second. Let me input the first string, then the second string. Okay. Now we can see that we have all the inputs are taken. For each test case containing integer, the minimum number of cells that need to be reprinted. Now we have to make the matrix here from the string, because working in the strings I don't think so good. So this will be a vector of integers. No, let me make it characters. This is the matrix. The column size will be 2 and the row size will be n. Now we will fill the content here. We are just taking input here, nothing great. So we will check here that if I is 0, that is we are working with the first first string, and if the first of j is equal to red, then in the mat of I and j we will make red here, else there will be a black, and mat I j we will push the black one. And else if you are in the second row, then we are playing with the second string given. So if the second string is R, then we just simply have to push the R, and in the other this character as black. Till here we just have taken the inputs. Now what I'll do is I just have to print the minimum number of what? Flips. So count minimum, something like this function, and I will start with 0th column, 0th row and 0th column, and pass our matrix here. Now the game is played by this function. This function will return a integer, taking our row and a column and a matrix of the character type we can take it as reference. Now we have to make a recursion. So what was our approach? Our recursion approach, we start from file 00 started. Now we check first vertical pair. At the end we have to return the minimum and horizontal. So for horizontal, we first take that the horizontal as int max. Okay, we have to take the minimum. Now we are going for vertical pair. We take horizontal and the vertical as int max starting. Now first we take the vertical pair. So for vertical pair, what we are doing? For vertical, we are comparing just ij to ij plus I plus 1j, that is the first row and the second row element. Okay, so there will be two conditions. If what? Our current element is equal to the below element, that means the horizontal will be count min, go to row, same row but go one column ahead and with the matrix. Else if these two are not equal, we have to add one to flip and count min with the same row and column plus one. I think till here for vertical pair the logic is clear. Okay. Now this time for horizontal pair. Okay, for horizontal what we are doing, first we have to check that column is not equal to n minus 1. Okay, if the column is not equal to mat of 0 dot size minus 1. Okay, so we have to check the first horizontal pair and the second horizontal pair, these two are equal or not. So if my current element is equal to my next element, and my just below element, that is this, is also equal to my diagonal element, that means we are making two pairs simultaneously and both need no flips. Then we simply return, not return, make in vertical the count min. Go for what? Go for the same row, but this time the column is +2. I hope you remember it. Now the second condition will be, the second condition what? The upper pair is not equal, need flip, and the below pair don't need any flips. So if you are not equal to just your next element, but your just below element needs no flip in making the pair, okay, then we just have to make only one flip in the upper one and go with the same for the column. Now the third condition is, that is will be else that both pairs needs flips, and we have to make the flip. Then we need to count the two. Go with the row, go with the same place with the matrix. Now at the end, what we have to do, we have to return the minimum of horizontal and the vertical. I think I have written the correct code. Let me test it out for given test classes. Okay. First we have to copy the test cases. Now let me run this code. Hope there is no mistake. There are multiple errors we are getting. I was not declared in this scope. Oh my god. We are playing with ij in place of row column. No problem. We make it tie. We make it the column for j. For the simple, we stay at I. Go for j. Stay at I. Go for j. Or we can simply do what? Is there any below row column? I don't think so. We can simply, for row, we replace with I. Place all. Now for column, replace this with j. Replace all. Let's check it out. Again, there is some errors. That is what? No matching function to call this. No matching function to call this vector. This is the matrix vector. We are passing the first size, and here we are passing the size of second. Okay. We take here int. Sorry. Next. Is it good for infinite loop? Oh, wait. We don't have make a base case where this recursion have to return. What can be the base case? The base case is simply if your column is greater than or equal to my n, then we just have to return the 0. That is, there is no need of flips. That we can't make any count here. Now let me run it. We are getting 10314. Okay, so I don't have making handle here. Next line. 10314. So this is the recursive approach, and it is passing the test cases, but when we try to submit it, it will give TLE, that is time limit exceeded. Okay, so now here the DP comes and we will apply memoization. So what we do for the memoization? We make a DP 2D vector. We make a DP here. What the size? Column row will be 2. For column, we will make it and 1 plus 1 for the base case, to store base case, and we will initialize with all with -1. First -1 Why this? No, it is storing the integer, that is the count of flips. I think I have made the correct DP array. Now we have to take an every function call. This is the DP. Now after base condition we will check that, hey DP, are you already calculated? If it said yes, then return that value. Why to calculate again? Pass the DP now. Okay, I will pass just a few times. I think everyone is good to go. Now let's check for this. It is working. Yeah, it's working. Sorry. Now using memoization I have optimized its time complexity, but still if we submit it for this question, we will not get any time limit exceeded, but we will get memory limit exceeded, because we are making huge memory uses, mere stack traces. Okay, so we have to remove that extra stack complexity. To do so, that we have to use tabulation. So to make tabulation, what we generally used to do, the same DP array we use, I think. Yes. And what we do for base cases, we first convert the base case. So if you think to convert the base case, that is when j is greater than or equal to mat 0, it is the nth. So now this time for tabulation. What we will do, we will take the DP array, DP, and for 0th column, if you are equal to mat size, that is the column size, if you for this we are storing 0, so here for the 1 also 0. So I have converted the base case to the tabulation. Okay, no need for this. Now we have to convert this into a for loop. So what we do, we have converted the base case. Every time we are going with I as 0, not going for I1 any time in the recursive approach. So we will start, we have make the nth, imagine the table. Okay, imagine the table we have created using DP, and the last column I have filled with 0 and 0. Okay, now we will start from the second last column. Okay, and we always lie in the first row, so we are here have taken the I as 0. So we will start from where, n-1, and go till 0, and just a minus. And the teacher said me, after writing the iteration, just copy the same logic of the memoization. Copy ho jao. I think I have copied it. Now I just need to paste it here. In this case, I have pasted some formatting issue. Just wait a minute. Oh, रुक जाओ. रुक गया. Tab. Okay, done. Now for all, there will be horizontal, there will be vertical. We will compare with this and this, the same. I will use here DP. go with I, go with j plus 1. J plus 1 already calculated. I think there is no need of these two things, I and j plus 1, I and j plus 1. Here the same I and j plus 1. Here also, here I have to print ij plus 2, dpi and j plus 2. Okay, now let me copy the same and paste it here. And at the end we are returning something. So what to write for this return case? Anyone guesses? We have an horizontal, we have an vertical. This is the minimum. I think we have to make this dpij as this minimum or horizontal and vertical. If I am right, then at the end we just have to print the where we have started in the memoization. We have to end at that point in tabulation. That is the bottom up approach. So I hope I have converted. Now let me comment it out. This tab memoization approach. Now let me run it, whether it is working fine or not. There is some error that is j is not declared. Oh, blunder, no declaration. Now the same I am getting. Okay, now this stabilized approach will submit, I hope, and not give any TLE or MLE. So this is the whole code. This was the approach. I hope the question, the solution, the logic and the intuition is clear. Thank you very much. Let us meet another interesting problem with the interesting solution. Bye bye.